Okay, so today we are going to talk about alternating current. Alternating current, abbreviation will be AC. So what happens in alternating current? Current changes its direction. One thing, current changes its direction means suppose the charge flow through a cross section is from left to right, then it will be also right to left, and net charge flow over a period of time in one cycle will be 0, two cycle will be 0. After every complete cycle, net charge flow will be 0, and alternating current will have a positive half, it will have a negative half. Charge flow in both halves will be 0, equal in magnitude but with a negative sign. So basically total charge flow is 0, and our attention will be on sinusoidally changing alternating current. Sinusoidally changing alternating current. So AC changes the direction of charge flow. One thing, net charge flow after any number of complete cycle will be 0. Okay, and magnitude of the current may vary, may not vary. Okay, so for example, I will give you one example where it is not varying. So this is time axis and this is current axis, and see, current is positive. Okay, and so it becomes negative suddenly, and for the same amount of time it remains negative. Okay, so it has a positive half cycle, it has a negative half cycle, and charge flow, magnitude of current remains same. And but only thing, what is the problem? No problem. There is no problem. Okay, the thing is, a sign of the current is changing. So current is going this way and this way, and this is one complete time period. Here magnitude of current is not changing, and the same thing will get repeated again and again. Things will continue. Okay, I have shown you only two cycles, but this thing will continue. So this is our square waveform. Apart from this, the most important thing is sinusoidal waveform. Sinusoidal waveform, what happens? Sinusoidally changing in AC, it will change sinusoidally as the name suggests. So uh, it is like this, and I have shown you two complete cycle. So it has a positive half cycle, it has a negative half cycle, and this is one time period. In one time period, one cycle is completed, and next time period, in next time period, same thing is repeated. Okay, and this will continue. Okay, and this looks like a sine graph, and it will be, its equation will be something like this: I naught sine omega t. Okay, right now it is I naught sine omega t. I will write a 0 here also. Okay, this angle is called phase, total phase angle. Okay, and here 0, and this is a particular case, here 0 is initial phase angle. Instead of 0, it may be pi by 2 also, it may be pi by 4 also. So I will show you example. I can use this graph also. I can use this graph, the same graph, to show the cosine one. Okay, so cosine one will look similar. Cosine one will look similar, but it will look like it is starting a bit earlier. Cosine curve is leading, so it will look like it is starting earlier. It is following the same type, same graph, but it is following the same graph, but it is starting earlier. I will erase this part. Okay, yeah, and this graph, oh, this one looks like I is equal to I naught sine omega t plus pi by 2, or it is actually the cosine graph, right? So cos omega t. So you can see that both sine and cosine curves are similar. Okay, same, only difference is some angle difference is there. Cosine starts a bit earlier. Okay, it is ahead by an angle pi by 2. Okay, so you have seen that this can be 0, this can be pi by 2, this can be pi by 4 also. Okay, let me show that part also. Okay, so pi by 4 will look like this. Okay, yeah, so the blue one, and I would erase this. Okay, it is blue one is I is equal to I naught sine omega t plus pi by 4. You can see that when t is 0, this will be sine pi by 4 and current still have some value. Okay, I mean, here current value will be 0 at time t is equal to 0. Here current value will be maximum at time t is equal to 0. In this case, current value will have 0.7, okay, 0.707 I naught. Okay, so that part 0, pi by 2, pi by 4, that is called initial phase. Okay, we will discuss it in detail, no problem. And our discussion will be this way, on this waveform first. Okay, sinusoidal waveform. So how can we get, the question is how can we get sinusoidal waveform, right? So how to get alternating current, how to get alternating current. And this example comes from previous chapter, electromagnetic induction. What we learned in electromagnetic induction, we had a loop, right? We had a loop, and this loop was rotating. Okay, and this loop was rotating about the axis. I am going to show that axis. Okay, no problem. And this loop was rotating about this axis, with an angular speed omega. Initially this is in a horizontal plane. So area vector of the loop is vertically upward. Area vector of the loop is vertically upward. I will denote it by A, and we have a vertical magnetic field also. Okay, everywhere in the region we have a vertical magnetic field. Okay, and the magnitude of the magnetic field is B. Okay, so right now what you see, we have a phase angle initially means at time t is equal to 0. Initially the flux is B into A into cos 0. Cos 0 because direction of A and B are coinciding. Okay, now one more thing, I have shown you one loop, right? It can be n number of loop also. How? Let us see. This wire is going this way, it is completing the loop, then completing the second loop, then completing the third loop. This way n number, after completing n number of loop, this wire is coming out. So this is our terminal. Okay, I have shown it positive and negative. After some time it may become negative and positive also. Okay, it is not necessary that it is first positive and negative. We will see. Okay, so basically what is my point, this polarity will keep changing. In DC polarities does not change, right? In DC we have two poles, and the potential difference between them is maintained. Here potential difference is not maintained, it is changing, it will be changing the magnitude. Also it will be changing the polarity. So what I discussed so far, it can be initially flux will be NBA cos omega t, cos 0. Now at time t, what will happen, it will rotate by an angle omega t, which what will rotate by an angle omega t, this loop will rotate by an angle omega t, and the area vector will be like this, right? I will show it. So this is our area vector. I have shown it by dotted line, and this angle is omega t, right? Okay, so flux at time t is equal to at any other time, it will be NBA cos omega t. Now we can differentiate it and we can use Faraday's law, right? Faraday's law to get the EMF. So EMF will be minus d phi by dt. We have a minus here, and if when we differentiate cos, we are going to get sine, right? So that this minus and this minus sign coming from the differentiation, it will become positive. So I will write a positive, and I will write NBA sine omega t. Okay, one more thing we are forgetting, the coefficient of this t. Coefficient of this t will also come here. Now this part, I will call this part E naught, EMF. Okay, E naught sine omega t. So what we get, we are getting a sinusoidally changing EMF. We are getting a sinusoidally changing EMF. Now what may happen, you can connect it with a wire also, resistance also, and this loop may have some resistance. So in this case, what we are going to get, current I is equal to E naught by total resistance R plus R sine omega t. Okay, now we get this thing. But I told you in general, but I told you in general, form was I is equal to I naught sine omega t plus some. This was the form, right? This phi naught in this particular case, phi naught is 0. It can be pi by 2, it can be 45 degree, pi by 4, any other angle. Okay, so how can we get that phi naught? Okay, let us see what I have done. I have kept the loop horizontal. So area vector is upward, b vector is upward, angle between b and area vector is 0. But maybe we can keep the loop vertical. So area vector is this way, b vector is this way, initial angle is pi by 2, right? If initial angle is pi by 2, then final angle will be omega t plus pi by 2, and we will get cos, right? For sine omega t plus pi by 2 will become cos. So cos omega t is also sinusoidal. Okay, sine omega t is also sinusoidal, and maybe this loop is not area vector is not vertical or area vector is not horizontal. It may be in between them, so it can be pi by 4 also. Okay, so far what we have seen, so far what we have seen, we can easily get this kind of sinusoidally changing current. Okay, now it is time to discuss all these things involved here. This is instantaneous value of the current, and this I naught, you can see that maximum current can be I naught. Okay, positive I naught or minus so negative I naught. Okay, it is just the difference of direction. Okay, so this is the peak value of the current, peak value of the current, peak value of the current, and this omega angular, this omega is called angular frequency. Angular frequency, and what is angular frequency? It is the rate of change in phase. Okay, but I have not defined phase, right? So I will define phase first. Okay, then I will discuss this part. Okay, this angle is called total phase angle. Total phase angle. Okay, total phase angle. And what is the meaning of total phase angle? It gives us full information about AC with respect to the time. I mean, you know the value of the time, you know all information about the current. How we will also see this part. Okay, and this is the initial phase angle. This gives us information about AC at t is equal to 0. At t is equal to 0, it will give you the information. So before talking about this, I will talk about this phase angle part. Okay, phase angle part. And this time what I want, I will to draw the graph again, and I would like to start this way. Okay, let me draw the graph. Okay, this graph doesn't look very good. Okay, so I will try again. Okay, yes, and I am going to erase this part. Okay, I have kept the phase angle. Instead of t, I will write omega t here. Okay, and here it is I, and here this is pi by 2, and this is pi, this is 3 pi by 2, and this is 2 pi, and 5 pi by 2. No, 3 pi by 2 pi, 3 pi by 2. Okay, yes. Now what you see here, it is cosine function. So initial phase angle is pi by 2. Okay, initial phase angle is what? Pi by 2. Its equation will be something like this: I is equal to I naught sine omega t plus pi by 2. You can clearly see that it is a cosine, right? So at time t is equal to 0, omega t is 0, but this initial phase angle is pi by 2. And because of this, you will get maximum value of the current at time t is equal to 0. Okay, so total phase angle initially is pi by 2. After some time, omega t is pi by 2, but total phase angle will become pi. Total phase angle become pi by 2. This omega t will become pi by 2. Pi by 2 plus pi by 2 will become 180 degree or pi, and the current value will become 0. Sine 180 degree, sine pi is 0. So it will give you 0 current. Apart from 0 current, after 180 degree, what happens? Sine decreases, right? So current will decrease. Current will decrease. So basically, if you know the argument of the sine, yeah, this is the, you know everything about the alternating current. This is called total phase angle. This omega t is called total phase angle, and phi naught is called initial phase angle. Okay, and how it is related to the angular velocity of the loop, we have also seen. Okay, this omega is also the angular velocity of the loop. Here it is angular frequency, and also phi naught is the original orientation of the loop. Phi naught is what? Original orientation of the loop, original angle the loop is making, loop's area vector is making with b. So we know all this information. Now angular frequency. Angular frequency, I have already written rate of change in phase. So that is total phase angle. What is the rate of change of this thing? This thing is omega. If you differentiate it, this part is constant, this will be gone, you will get omega. That part is constant. Okay, so angular frequency is constant here, rate of change in phase, okay, in our AC it will remain constant. Okay, and how this rate is changing, okay, you know that one cycle will be completed if you go from here to here. Phase angle is changed by 2 pi, right? Phase angle changes by 2 pi, and we also know that one cycle is completed, right? From here to here one cycle is completed. I will denote it by I will draw it by red. From here to here you can see that one cycle is completed. So phase angle is changed by 2 pi. Why I am saying 2 pi? Sine or cosine, they repeat their value after 2 pi. They complete their cycle after 2 pi. So phase is changed by 2 pi. And this thing has happened in one time period. What is the time period? We know the definition of time period. Time period is the time taken to complete one rotation on, sorry, one cycle. Here there nothing is rotating, it is completing one cycle. Okay, current is coming at the same status in one time period t. So looks like I have defined everything here. Time period is time taken to complete one cycle. Okay, and I am talking about phase and phase. Okay, so one thing is coming, and that is called phasor. We will discuss about phasor also. I think it is good time to discuss about the phasor, then we will go ahead. Okay, so okay, phasors definition is difficult. Okay, I will write the definition part later. I will give you, I will do some simple mathematics. I will try to add two. I will try to add two alternating currents. Okay, and we will see if we can have some general rule. Okay, generalization. Mathematicians do these things. Okay, they do the mathematics. It is lengthy, and after that they try to see the pattern. After that they try to see the pattern, and then they think, oh, can we do some generalization, can we do some abstract way of dealing these things. So let us say one current is a sine omega t, and other current is b sine omega t plus some phase angle phi, initial phase angle phi. Okay, so what will be the total current? Total current will be a sine omega t plus b sine omega t plus phi. This kind of calculation I believe all of you have done earlier, so I will be a bit in hurry. Okay, so a sine omega t plus b sine omega t into cos phi plus b cos omega t plus, oh sorry, into sin phi. Now we are trying to club the sine omega t part. So a plus b cos omega t, no, b cos phi sine omega t into sine b sine phi cos omega t. Now what I am going to do, this part, let us say okay, r cos alpha. This part I am saying it is r cos alpha, and this part is r sin alpha. Okay, it looks like we have done something like in vectors. Okay, vectors in other chapter, like simple harmonic motion. Okay, so what will be r will be r cos alpha the whole square plus r sin alpha the whole square, right? It will become r. So when you square this thing, it will become, we have done this calculation. Okay, a square plus b square cos square phi plus 2ab cos phi plus b square sin square phi. Okay, b square sin square phi. Now you can see that we have a square, we also have b square, right? A square plus b square, and then we have 2ab cos phi. So the result I will write in the next page. Okay, in the next page what I will write this thing. Okay, in the next page I will write r is equal to a square plus b square plus 2ab cos phi. This reminds us the resultant of two vectors at an angle phi, right? We have two vectors of magnitude a and b, angle between them is phi, so resultant of the vector will be this. Okay, also I will write this thing. That tan alpha here is tan alpha. What is tan alpha here? Tan alpha will be b sin phi, because r sin alpha by r cos alpha. R sin alpha by r cos alpha will give you tan alpha. That means b sin phi on the top, a plus b cos phi at the bottom. B sin phi at the top and a plus b cos phi at the bottom. Okay, now I am ready to go on the next page. So what happened here? We have two currents. We had two currents. I is equal to we are trying to add two currents, a sin omega t plus b sin omega t plus phi, and what we got total okay, in back side we are coming back here. Okay, we are coming back here. This result I did not write. Okay, this result I did not write. See, this is cos alpha into sin omega. If you take are common, what you will get, what you will get cos alpha into sin omega t and sin alpha into cos omega t. So this is sin omega t plus alpha. This is what? Sin omega t plus alpha. Think again. This is r cos alpha into sin omega t. This is r sin alpha into cos omega t. Okay, so r is taken common and we will get this result. R is also known, alpha is also known. Alpha is also known. So I will write this thing in the next page. What we get here, we get yes, r sin omega t plus alpha, where r was a square plus b square plus 2ab cos alpha. This kind of thing we have done again and again. Okay, and tan alpha is b sin phi by a plus b cos phi. Okay, this result looks like we are adding two vectors at an angle phi, right? So remember addition of two vectors. One vector had a magnitude a, other vector had a magnitude b, and we added it using the triangle law or parallelogram law, anything, and we get resultant vector, and we got the resultant vector this r. Okay, so magnitude of this resultant vector was a square plus b square plus 2ab sin theta. And what is theta? I am not showing. This total angle is theta, right? And this angle alpha was given by, alpha was tan inverse b sin theta by a plus b cos theta. So you can see that we are adding current. There is a phase difference between them. I did not define phase difference, but it is clear. This angle is omega t, this angle is omega t plus phi. So phase difference is phi. This is ahead by an angle phi. So phase difference between the two current is phi. Okay, that is the phase difference. So I will in the next slide, what I am going to do, I am going to do comparison. Okay, these things are called phasors. Okay, sinusoidally varying physical quantities are called phasors. Their mathematics is similar to vectors. What are the similarity? We will discuss. Okay, their mathematics is similar to mathematics. Okay, their mathematics is similar to vectors. We will discuss the similarity. Okay, so first we have vectors and then we have phasors. And one more thing, here the phasor is current. Phasor can be EMF also, flux also, any quantity that is changing sinusoidally. Okay, clear? Cos omega t or sin omega t. And in SHM we have added what velocities, we have added displacements. Okay, okay. So these are phasors. Now in vectors we have magnitude, right? Magnitude. So magnitudes A and B, A and B was magnitude, right? And in phasors we call them peak values, A and B. You can go to the previous slide and see. You can go to the previous slide and see that we are adding two currents. First current has peak value A, second current has peak value B. So they are peak values. Okay, so they are peak values. And here instantaneous, the projection on vertical axis, that is instantaneous value. Okay, instantaneous value. This part looks like I did not explained too much. Okay, so I will do it again. Okay, I will do it here, no problem. So this is our vector A, this is our vector B, and this is our R, and this R is a square plus b square plus 2ab cos theta. This is vector A, this is vector B. Okay, and the projection of I will show some dotted line. This projection is R sine alpha. Okay, so this length is R and this angle is alpha. Okay, this angle was theta. So this R sine alpha is the projection of this vector on vertical axis, and let us see the similar thing is happening here. We have a current, and this current is denoted by A sine omega t. Okay, so let us say this is the reference axis. Okay, I am showing one reference axis also. Let us say this is the reference axis. So its projection on the reference axis, everything is on the x-axis. No, okay, sorry, yeah, this is along the reference axis only, and the other phasor other phasor B sin omega t plus phi. This is ahead by angle phi, right? So we have two phasors, A sin omega t, let us say omega t is 0. Okay, and this is B sin omega t plus phi, so basically B sin phi. Okay, and what we are getting here when we are summing, I will show it by red color. Okay, we are getting this thing, we are getting a square plus b square, a square plus b square plus 2ab sin phi. Okay, and this is the resultant. Okay, this is the resultant current. Okay, this is the peak value of the resultant current. Magnitude is like the peak value of the current. What about instantaneous value of the current? We will see instantaneous value of current. For instantaneous value of current, we will see the projection on vertical axis. Okay, you can clearly see that this is r sine alpha, and alpha is this angle, right? Alpha is this angle. So we have to find, if you have to find the projects, wait, let me do it. So our current will be I is equal to a square plus b square plus 2ab cos phi sin omega t plus alpha. Yeah, uh, I am taking omega t is equal to 0. Okay, now this is 0 angle, this is phi angle, and this is making angle alpha. So r sin alpha, this part is r sin alpha. This gives us instantaneous value of the current. Okay, now one more thing, phasors are rotating vectors. Okay, phasors are like rotating vectors in the space. So when the time is changing, this angle will become, so this angle will increase by, let us say, pi by 2. So this will go like this. Okay, but it will also turn, both vectors will turn. Okay, so and the resultant will also turn by 90 degree, everything will turn by 90 degree. So this will become omega t plus pi by 2, this will become omega t plus phi plus pi by 2, and this will become omega t plus alpha plus pi by 2. So everything will turn, but what will happen, the peak value will be given by the same formula. Suppose two vectors are these are two vectors and they are changing by 90 degree, angle between them, both are rotating by 90 degree, angle between them still remains the same. Magnitude, their resultant will still be the same. What will be different then? Different will be their projections on uh, vertical axis, their projections on horizontal axis, that will be different. Okay, if you turn these two vectors, then resultant will be the same. What will be the difference? Difference on horizontal, sorry, projection on horizontal axis, projection on vertical axis, they will be the different. Here it is the same case. So okay, back to the basics. And here uh, angle between angle between the vectors, angle between the vectors, here angle between the phasors, actually it is called phase difference. Okay, this angle is called phase difference. Angle between the phasors, we call it phase difference. Okay, good. Now okay, what else we need to say? Yeah, so we are going to the definitions now. Okay, phase. Okay, one more thing is there. This addition was possible because both phasors had same angular frequency. Here also omega t, here also omega t. Resultant also has omega t. It is rotating by the same angle. Other one is also rotating by the same angle. Resultant is also rotating by the same angle. That is why we are able to add. If its angular frequency is omega t, its angular frequency is 2 omega t. If it is turning by 90-degree angle, it will turn by 180-degree angle. So we will not be able to get this result. Okay, we will not be able to use the vector law. Okay, vector law. So the important part is their angular frequencies should be same. Okay, we will use some examples also. Why are we doing these things? Okay, so first phasors. Phasors, phasors. These phasors are sinusoidally varying physical quantities, physical quantities, which can be added like vectors, vectors. Okay, which can be added like vectors. Here, here, peak value correspond to the magnitude of the vector. Okay, and angle between the vectors. Okay, phase difference range correspond to the the angle between the vectors, and projection on vertical axis, projection of on vertical axis represents the instantaneous value of the phasor. while the phasors must have phasors must have same angular frequencies. Okay, this part is necessary when things are in omega t. Okay, this part is necessary when things are in omega t. For example, you already know the total phase angle. This part is not necessary for instantaneous values. Okay, if the values are already given, angles are already given, you simply add them. Okay. Okay, now we will see some example first. That will be better. So, for example, we have current. Let us say we are adding 5 ampere current sin omega t, and again 5 ampere current, uh, again 5 ampere current sin omega t plus pi by 3. So what we can see, say, let us say this is 5 ampere sin omega t. Okay, this angle is omega t. So other angle is if this angle is pi by 3, then we can say that this phasor is 5 ampere sin omega t plus pi by 3. The phase difference is pi by 3, and I will, and the resultant will be this. Okay, from the vectors we remember this part. When two vectors of same magnitude are inclined at 60 degree, we get root 3 times of that magnitude. So we are getting what? This will be root 5 root 3 ampere sin omega t plus, what will be this angle? Clearly this is 5 ampere, this is 5 ampere, this angle will be half of pi by 3. So we are getting pi by 6. So clearly we have an advantage, we can easily add these things. Okay, now I will give you other example. In the other example I will show by red color. This is easy example. Okay, so first current is 3 ampere sin, it can be voltage also, no problem, sin omega t, and other one is 4 ampere cos omega t. This kind of thing we have in trigonometry also. Okay, so 3 ampere sin omega t, and this thing I will try to write both, either in terms of sine or in terms of cos. So let us use in terms of sine. So this will become 4 sine omega t plus pi by 2. So the other one is ahead. So the first phasor is this. I will draw it first. Okay, so the first phasor is this, and the second phasor is this. This one is 3 sine omega t. Omega, suppose omega t angle is this horizontal. Okay, so other angle, which is omega t plus pi by 2, will be clearly vertical. So this is 4 sine omega t plus pi by 2, and the resultant is this. you know, when angle is 90 degree, our job is easy. So this will be 5 sine omega t plus this angle. This angle alpha is clearly tan inverse 4 by 3, but I will write, you know, this value for this angle, but I will write tan inverse 4 by 3. So we can add it easily, right? And before we go ahead, it will be great if you see one more example. What happens in three phase, you know that three phase AC, first phase AC, you have heard this thing, okay? So what happens, we have different type of wire. Some wire is blue, and some wire is red, some wire is yellow, okay, and they are getting added and we get neutral, okay. So why are we getting neutral? Let us see. One of the current is I is equal to, let us say one big current, okay, 100 ampere sine omega t. other one other one is ahead by an angle, phase angle 120 degree. 120 degree means 2 pi by 3. And again third one is ahead by an angle. Neutral one I will show it by some white color, okay. Other one is ahead by an angle 2 pi by 3 again. So 2 pi by 3 plus 2 by 3, it is 4 pi by 3, right? When you add it, I is equal to I1 plus I2 plus I3. Okay, we can treat them like vectors, okay. So the yellow one first, okay. So yellow one, this is omega t axis, okay, and then we have a red one, right? Red one is ahead by an angle 120 degree. Then we have blue one, right? And blue one is again ahead by 120 degree. So you can see that we have three vectors, and all these vectors are differing by 120 degree, right? And here the vector sum will be 0. So phasor sum will be 0. So we are going to get 0. So here there is no current, okay, no current, 0. So when I was young, I used to touch the neutral wire, okay. So neutral wire was not exactly neutral, there was still a small amount of current, okay, because maybe they are not exactly equal, okay. I used to enjoy that current, okay. So I will finish my lecture right now. Thank you.